Hello and welcome to this quick presentation on diagnosing looseness. My name is Jason Tranter, the founder and managing director of Mobius Institute, and Mobius Institute provides vibration training and accredited certification. Looseness is basically caused by improper fastening techniques, improper bearing installation techniques, wear within the bearing, excessive forces that damage foundations or grouting, or loosening the fasteners. For example, unmatched shims, loose bolts, corroded shims, missing bolts in this particular case, as we'll see. There you can see the missing bolts and loose hold-down bolts and damaged seals. You can see the leaking going on here and the screwdriver that's wedged underneath. So, there are actually three forms of looseness that we can diagnose with vibration analysis. Type A is called structural looseness or weakness. So it's weakness in the base plate or across welds or foundation problems and so on. It usually takes a little bit of vibration, for example by unbalance, to make the machine want to move up and down and move from side to side. And if the structure is weak or loose, then it is allowed to vibrate in that way. So in this particular case, we expect to see high vibration at the running speed, because that's how it's rocking back and forward, generally in the vertical or horizontal axis, wherever it is free to move. We can use phase to diagnose this fault, but more so that we can rule out other things, for example, unbalance or resonance. It can look like resonance because the vibration is much higher in just one axis. So here's a animation just showing the motor rocking back and forward. Type B, on the other hand, is where we have a cracked structure or pedestal bearing looseness. It's sort of specific to a type of machine and fault condition, but we will see perhaps some high 1x, maybe 2x, maybe 3x. The phase will be very erratic. So this is the type of situation we're looking at, is where the pedestal bearing is loose and it's able to sort of move up and down. In this case, it's not impacting, otherwise we'd have a lot more harmonics. It's just free to sort of float up and down. We might see it, more like this, but no impacts. Type C is the more common form of looseness, what most people think of when you talk about looseness, and that is where you see the high 1x peak and all those harmonics, and those harmonics can be very strong. In other words, rather than dropping off in amplitude, we might see them at a similar amplitude or growing amplitude across the spectrum, and that's because there is impacting occurring. That might be the bearing moving within the shaft, as I'll show you in just a moment, or moving within the housing. One of the keys is not only do we see a lot of harmonics, but often the noise floor raises up. Because of the impacting, we cause resonance and the noise floor can move up, and because we're causing so much noise. So this is one attempt at the sort of vibration we might be having, where there's enough clearance and it's just kind of bouncing around in there. Here's another case where the bearing itself, the whole bearing, is moving within the housing. Now obviously these animations are exaggerated in terms of the amount of clearance and in the exact motion that would be observed, but the bottom line is we'll see all the harmonics, and that's an indicator of this type of fault. So, in conclusion, looseness can be an indication of poor maintenance practices or high vibration that's brought on some sort of failure, or the failure of a component, for example a crack or a broken weld or something like that. Rotating looseness generates harmonics, but not every spectrum that shows harmonics indicates that looseness exists. That's a trap that some vibration analysts fall into. They see a spectrum with lots of harmonics and say, oh, there's looseness. And not only is there not a looseness problem in many cases, but the poor maintenance people are wondering, well, what is it I'm supposed to fix? Give me some more information. Structural looseness can easily be confused with resonance because it's high amplitude and directional, but the type of solution is very different, and it can easily be diagnosed that it's one or the other. And spectra, time waveforms and phase should all be used to correctly diagnose looseness. For example, with rotating looseness, the phase is very erratic and the time waveform will show the impact. So I hope you found this quick presentation useful in the explanation of looseness. Please contact us if you have any questions.